Welcome back everyone. In today's session we are going to see one of the most important theorem of triangles, that is basic proportionality theorem, which is also called Thales theorem because Thales was the mathematician who studied about this. So first before we start our theorem, we'll discuss few important concepts which will help you to understand the theorem easily. Okay, so let me explain you the theorem roughly first. Let's have a glimpse of this theorem. According to this theorem, if you take any triangle, okay, say this is a triangle ABC, okay, take a triangle ABC. This theorem says that if a line is drawn parallel to one side of a triangle, okay, if a line is drawn parallel to one side of a triangle to intersect the other two sides. So I have drawn a line, you can see a yellow colored line DE, okay. If a line is drawn parallel to one side, so this DE is parallel to BC. DE is parallel to BC. So this theorem says that if a line is drawn parallel to one side of a triangle to intersect the other two sides, okay, at two distinct points, then the other two sides are divided in the same ratio. So the main concept here is this line divides the other two sides in the same ratio. So the other two sides are AB and AC. So these sides will be divided by this line in the same ratio. So what do you mean by same ratio? That will be AD by DB. Okay, this side by DB will be equal to AE by EC. This ratio will always be equal. So this is our theorem. So if a line is drawn parallel to one side of a triangle to intersect the other two sides at two distinct points, then the other two sides are divided in the same ratio. Okay, so however you draw the triangle, that doesn't matter. Now if I take another triangle, say a triangle PQR this way, okay, I can draw a line parallel to any side of this triangle, okay. I can draw a line parallel to any side. I can draw a line this way parallel to PQ, or I can draw a line this way parallel to PR, or I can draw a line in this way parallel to QR. So however you draw the line divides the other two sides in the same ratio. So if I take another example, like if I draw a line parallel in this way, okay, this way, if I draw a line parallel to PQ, suppose the line, I'll name the line as XY. So how will be the sides divided? The sides will be divided in this way, RX, okay, RX by XP, RX by XP is equal to RY by YQ, okay. So however you draw a line parallel to one side of a triangle, that line will divide the other two sides in the same ratio. That is the theorem, Thales theorem. Now before we go for the theorem, let us see few more concepts. If I directly explain you the theorem, then you may get confused over there. So let's see, clear few of your confusions. Now hope you all remember the area of triangle formula when base and height is given. Suppose if you have a triangle ABC, let me write ABC, if you want to find area of this triangle, hope you remember how you used to find area of triangle when base and height is given. When base and height of a triangle is given, this is the base and this is the height, so we use the formula half into base into height. So remember this formula, we are going to use this formula in the theorem. Another important concept which we have to remember is triangles on the same base and between the same parallels are equal in area. So we have done even this theorem in 9th class. Okay, triangles on the same base and between the same parallels are equal in area. So if I draw two triangles this way, if I draw two triangles on the same base, this is the same base and between the same parallels, so we used to say that they are equal in area. This was one of the theorem in 9th class. So first thing you need to remember area of triangle. Second, you need to remember this theorem, triangles on the same base between the same parallels are equal in area. And the last, one more thing before we go for this, if I take a triangle, say this is a triangle ABC. Okay, what is the base in this triangle? This is the base and this is our height. Okay, this is the height of the triangle H. Now if I draw another triangle in this way, if I draw another triangle like this, or if I draw one more triangle, so for these triangles the base will be different and the height remains same. Okay, keep this in mind. If you draw a triangle in the slanting way like this, how do you measure the height of this triangle? Height will be measured in this way only. This will be the height. Okay, so this is the common height for all these three triangles, 1, 2 and 3. If you draw some more triangles also, will take the common height, only the base differs. This is the base differs in this. This is the base for this triangle, this is the base for the other one, this is the base for this green colored, but height will be common for all of the triangles. Okay, these are the three things you must remember before we go for theorem. So I explained you, I just gave you the glimpse of the theorem, what the theorem says, and then I said you however you want you can draw the line parallel in any direction. Then I said you the area of triangle formula, half into base into height. Then we saw this theorem, triangles on the same base and between same parallels are equal in area. And the last thing is the height remains common if the triangle lies between the same parallels. Okay, I say they lie between the same parallels only here. Okay, so the height remains same. These all things will help you to understand the theorem very easily. Let's begin our theorem now. So the theorem definition you can see here. This is one of the most important theorem. Mark it, everyone. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio as I said you just now. So here we will take a triangle. In the exam only the statement can be given or only the name of the theorem will be given, state and prove Thales theorem or state and prove basic proportionality theorem. So you must write the statement also along with the proof. So we'll take a triangle ABC where DE is parallel to BC. Okay, so when DE is parallel to BC, we need to prove that AD by DB, you can see here RTP is equal to AE by EC. Okay, AD by DB is equal to AE by EC. We need to prove this. So for that we'll do a little construction. Because for finding area of triangle we need the height of triangle. So we'll draw EN perpendicular to AB. You can see a line EN perpendicular to AB, and we'll draw DM perpendicular to AC. Okay, DM perpendicular to AC. See that they are perpendicular. Then we'll also join BE and CD. BE and CD. You can do all this in one figure only, or you can draw two separate figures. Okay, so for your convenience I have used different colors here. Now So hope till constructions it is clear to you all. Given, required to prove, and construction, these are the constructions which we have done. Now we'll find area of triangle ADE, the green colored triangle. We'll find the area of that, half into base into height. So what is the base in this triangle? Half into base is AD and height is EN. Okay, what is the height in this triangle? AD into EN. Then I'll find the area of this triangle BDE. Okay, they are in this way, just you can have a look. This way we'll find the area of this triangle and this one BDE. So area of BDE will be half into BD. What is the base in this? In triangle BD, the base is BD and height will be EN only. Just now I said you, okay, previously I said you, however you take a triangle, if they lie between the same parallels, then they'll have the same height. So for this triangle also we took the height as H only. So here also I am using the same concept. So area of BDE will be half into DB into EN. Okay, then next, coming to the next triangle now. Next part, area of ADE. Again we'll find area of this triangle twice. So ADE, area of triangle ADE will be half into base into height, but this time I'll use another base. I'll use the base AE and the corresponding height of this is DM, half AE into DM. Then we'll find the area of the other part. I said you just now that we'll find the area of triangle in this manner here, this way. Okay, we'll find area of this triangle, and the other triangle is CD or DEC, this one. So area of the purple colored triangle, I can say here green and blue, here green and purple. So area of purple colored triangle, that is DEC, is equal to half into EC into what will be the height here? Again DM only. Okay, that will be the common height, half into EC into DM. So this way we'll find the areas of the triangles. Now we'll go to the next part. We'll divide 1 and 2. This 2 will divide, and we'll also divide 3 and 4. Okay, area of ADE by BDE, area of ADE by DEC. So we'll do division in the next step. So here you can see I have taken those steps again for your reference. Now dividing 1 and 2, that is area of ADE, because we need the ratio of sides, so we are dividing the areas of triangles. So area of ADE by BD. What is area of ADE? Half into AD into EN, and area of BD is half into DB into EN. Okay, so I have divided them. Now what can I cancel in this? I can cancel EN, here half and half, remains AD by DB. Similarly, I'll divide equation 3 and 4, that is ADE by DEC. So we get half into AE into DM, and this half into EC into DM. So these both areas are divided. Again here DM and DM gets cancelled, and half gets cancelled, remains AE by EC. Now we'll use the theorem which I discussed before. Now you can see this triangle BDE and DEC. These two triangles, the blue colored and the purple colored triangles, are like this. They are on the same base and between the same parallels, isn't it? BDE and CD, they are on the same base and between the same parallels, because we already said these two are parallel. So the areas of these two triangles will be equal. Okay, and numerators are already equal, ADE and AD. Denominators also became equal. So finally what can I say? I can say that these both are nothing but they are equal. So now triangle ADE and BD and DEC are on the same base. You can write the statement, and between the same parallel lines BE and DC, DE and BC. So we can say area of BD is equal to area of DEC by theorem. So we said that the blue colored and the purple colored triangles are equal in area by theorem. So finally I can say that this A and B are equal. ADE by BDE is equal to ADE by DEC, because these two became equal by theorem and these two are already equal. So when these two are equal, their right hand sides will also be equal, that is AD by DB is equal to AE by EC. Hence we proved the theorem that if a line divides two sides of a triangle, if a line intersects two sides of a triangle, then the two sides are divided in the same ratio. This is one of the most important theorems. So theorem starts from here and ends here. Only the last two pages includes theorem, and these all remaining pages are just basics for understanding theorem.